Okay. All right, ready to start. Okay, we're going to look at a bunch of transformations today, like 6 or 7 of them. There's a lot today. What a transformation is a change in the position, shape, or size of a figure. Okay, so these first couple we've had before. What's a translation? What happens when you translate an object?
It goes up or down on the y-axis.
Up or down.
Or left or right. So you're sliding it. Slide is what we're going for. So again, this first one's review. We've talked about translation before. We're going to plot this, make a triangle, and we're going to translate everything right 4 and down 1. Okay, to get everything to fit nicely, you're going to have to put your y-axis over here, and your x-axis kind of in the middle. Okay, first thing I want you to do is plot A, B, and C, and then connect them to make a triangle. So just plot. And translating is very easy to do when you have the graph sitting right in front of you. But the whole goal today is to come up with little shortcut rules so we don't have to graph everything. And like I said, some of these we've done before. Okay, so I'm going to move each point right 4, down 1, and then give the new ordered pair here. So let's move A first. Go right 4, down 1. Did I put one of these in the wrong spot? I put C in the... Why didn't you tell me these things?
Okay, I thought I did it wrong.
Oh, God. How many of you copied mine instead of doing it the right way? That's what I want to know.
I did nothing wrong.
I did. You're supposed to tell me when I do things wrong.
I just thought I got it wrong. I was gonna question it. We forgot D.
D is for later.
Yeah, why is there...
D is for later.
Why is water?
There's a reason, because we want to come with a shortcut. Let me get my C in the right spot. -1, -2. I did 1, 2. Okay. Try this again. Okay. Now, move right 4, down 1. I knew it wasn't supposed to be inside the one that was already there. So there's A prime. So where did A prime land at? It was at -3, 0. Where is it now?
1, -1.
1, -1. Okay, now let's move B. Not difficult to do when the graph is here. You just count right 4, down 1. Where is that at? It is at 6, 2, and then C. 1, 2, 3, 4, down 1. Three, -3. Okay, I would like to know a little shortcut. If I know the x value and the y value, like I did here, how can I get the new image point without graphing and counting? Knowing that I'm translating right 4 and down 1.
Add or subtract. Add or subtract.
If I'm at -3, and how did I get the 1?
You add 4.
I added 4 because x, think about x. What direction is the x-axis in?
Horizontal.
Horizontal. And going right is the horizontal move. So all I'm doing is adding 4 to that x value. So it's going to be x plus 4. And going down is a change in which letter? The y, because the y-axis is going up and down. How do I go down 1?
1 plus 1.
Subtract 1 from the y value, and you see they're all 1 smaller than what they were. So, using this shortcut, where will D land? What's negative 110 plus 4?
Negative 1.
Negative 106. Negative 6. Okay, but translations don't all have to go right 4 and down 1. Correct? I can slide left and I can slide up and down. So we're going to call H is going to represent our horizontal movement. Horizontal movement. And we're going to let V equal our vertical movement. So in general, this is going to be our rule for all translations right here. If I've got a point and I'm translating it, I'm always going to add the horizontal movement onto the x, because x is our horizontal axis, so it's going to be x plus whatever h is. If it's to the right, I add. If it's to the left, I subtract. And v is going to, vertical movement is going to get added to the y, so y plus v. There. Are the triangles the same size or different size? Same, so they're congruent to each other. So here, on a translation, the triangles stay the same size. So triangle ABC is congruent to triangle A prime, B prime, C prime. So translating does not change the size, it just changes its location. Okay, next thing we're going to do is a reflection. And we've got 2 different reflections. We're going to reflect over the y-axis and over the x. What are we doing when we reflect something over a line? Flip it. We're going to flip. Okay? You can put your y-axis in the middle here. And your x-axis in the middle. Oh, we'll go 1 down from the middle. Okay, plot your A, B, and C, make a triangle. And then plot the D as a separate point. See if I can plot them right this time. I'm just doing a triangle and a point. Okay, we want to reflect this thing over the y-axis. What's my process I have to go through to do that? What do you count out to do this?
To the y-axis.
To the y-axis. So if I count, A is 1 away from the y-axis, so I'm going to go 1 away on the other side. So where is that at? What's that ordered pair there? Negative 1, 1. Okay? So you're counting to the y-axis, and then you go the same amount on the other side. So 1, 2, 3. So where is that at?
Negative 3, 2.
Negative 3, 2. And then the C,
Negative 4, 5.
that negative 4, 5.
Does D stay where it's at?
D's got to flip over the y-axis too. That means it's going to jump back over here in the first quadrant. And where's that at? 1/4. So, we would like to have a rule, a shortcut rule, so we don't have to graph when we reflect over the y-axis. So, where is this new x value coming from? From what? This one's not negative.
Reciprocal? Yeah.
How does it compare back to this original point? What's changing?
Just the positive value.
What's changing?
The value X.
The x value is changing, because I'm shifting its horizontal movement. I'm flipping it to the y. So this was a 1, now it's a -1. This was a 3, now it's a -3. A 4 went to a -4. A -1 went to a +1. So how do I write that down here? If I start with an x, y coordinate pair, I take the opposite of the x. When you see a negative, that means take the opposite of whatever it was. What about the y values? How do they compare back to the original? Exactly the same, because it's got the same height. All I'm doing is changing its horizontal position. So the y part stays the same. So, using this new rule, where would E land if I reflected it over the y-axis? -22, and where on the y? -99. So you take the opposite of the x, and you keep the y the same. Are you good with that rule? Okay. Let's reflect over the x-axis. Let's put the y-axis over here. X-axis in the middle. Plot A, B, C, make a triangle, and then D is by itself again. I think it's the same triangle we had. Okay, this time we want to flip over the x-axis. So we're going to flip it down. So what letters would you expect to change because you're flipping it down? You would expect the y's to change. Let's see if they do. So to flip over the x-axis, we're going to count to the x-axis. So A is 1 away, 1. That 1, -1. And flip D. Does anybody have the shortcut for us? What is it? So keep the x the same.
Yeah.
All the x's are the same, because I didn't shift this thing left or right. It's still in the same horizontal position. But the y's changed to the opposite of what they were. So where will E land? 22, +99. Okay, did the size of the triangle change because I flipped it? On both of these, the triangles are the same. So triangle ABC, I forgot to write it down, is congruent to triangle A prime, B prime, C prime. And then here, triangle ABC